So I'm just going to open Tracker and start by opening Tracker, and we'll just use Tracker to get position and time. What I'm not doing anymore is I'm not using Tracker to get velocity. I'm making a new column for velocity in Logger Pro.
You just drag the file on there instead of having to open it.
Oh, that's cool. Is this your video?
Yeah.
Right here?
Yeah.
Okay. All right. That is cool. Now, your car is going to be going in the negative direction then, because it's going from left to right. I think this is a very unique pattern you created.
That's kind of why.
Is that what you've been using?
Well, I've done like 4 different ones and it just hasn't been following it.
Okay. Have you tried like the truck?
Yes, I have.
Gosh, this should work great. I'm just going to try this because I think that pattern is so unique. And let's see what happens. And is there anything in frame that we know the size of in meters?
We can
Like your car?
measure the car.
Okay, why don't we go from center of the LP record to the center of the CD, it looks like, in the front? How many meters is that? Okay. And then I'll just keep going with the analysis. I'm going to go create point mass. That's what you did.
Here. If I measure the center, can we just do it from like the axle to the other
Sure,
axle?
that'll work fine.
Here, I need to this is
Yeah. You have to look around. I saw some string outside, some fishing line that used to be mine. I saw it by the tree on the ground, I think. Sabrina, another way to do it is say, hey, anybody got any extra string or see any string for Sabrina? There's some. People generally will help each other. It's good.
The screencast is still going.
Oh, sorry.
27.5 inches.
Okay,
So.
inches, you may want centimeters. Sorry to be that way, but it'll make the kinetic energy calculation easier.
Yesterday.
Yeah.
So I'm telling this, and it
Let me
won't.
pause this screencast real quick. So you told me just now that this is 0.68 meters. 0.68, 0.68. So now we have our calibration stick done. Now let's see. I didn't create a point mass yet. I got to create a point mass. Create point mass. Okay. And you've tried this probably exactly how I'm doing it, I'm guessing. Now, so when I click here, I'll just try. Okay, there is a way to make this bigger, but it looks like you tried that too.
Yes.
Okay. Huh. Well, I'm just going to see what it does. Okay. It looks like it's working so far. It might be one of those annoying things where you try it a million times, it doesn't work, I do the same thing and then it works. That would be really annoying if I were in your shoes.
It seems to happen with computers.
All right. It looks like it's doing okay.
Okay, then I can.
Just pray. Well, I might as well carry through the rest of it with you, because doing the analysis is one thing, but explaining it is what we're really going for here. And it will help a lot of people, I think. I made a screencast just like this with a homie in first period, and it seems like it could help a lot of people get the job done.
Is this a bucket of trash?
That's my bucket of things to do.
There's a fork in there.
Sometimes I think of it as trash, though. Usually it's bills. There's some bills in there.
Is that really?
There's receipts. There's basically probably like a couple $100 in money because
What is the
there's
fork?
materials I have to take back. All these receipts.
Okay.
Look it's doing a good job. I'm checking over here. Look at how amazing your data is looking, Bailey. This is like incredible data. See how smooth that graph is?
Is it doing both graphs at the same time, or is it?
I'm not going to worry about using tracker to get velocity. I just want the graph you see there, the position and time. Any questions about this? I mean, this is exactly what we'd expect to see. In the beginning, the slope gets steeper. Why?
Speeding up.
Yeah. And then in the middle, we kind of have a straight line because maybe your car goes at constant speed for a while. Or you could say the car speeds up and then it does what?
Coasts.
And so as it coasts, is there friction?
So there is.
So it's
but
probably going to slow down. So what we see here is two curves. In the beginning, right here, we have a curve that gets steeper and it's concave down. Over here somewhere, it should become a concave up parabola where the slope's getting less steep. You guys know what I mean by concave up, concave down? Concave down is in the beginning when the parabola opens downward. Concave up is going to be in the end where the parabola opens upward. Does that make some sense?
So it's just.
This is yesterday.
Okay, hold on. Go ahead.
This was supposed to be screwed. The hole was supposed to be screwed here.
Okay, I'll go outside and I'll do that as soon as I can. I got Caesar to help over there too, so I'll help both of you in one shot.
How did you get the measurements? Hold on.
How did we get what?
How did you change what this was right
The
at?
calibration stick?
Yeah.
Okay, you go, to do the calibration stick, you click on this button, and you click on that arrow, and then it says new calibration stick. And then just this button here, not the arrow going down, but this button, makes it disappear from the movie. Okay? Because you don't want it to be there while you're collecting data, it kind of is in the way. But if you click on that arrow, it helps you. See, I'm using calibration stick A that I created, and that's my calibration stick.
All right.
Hey Bailey, check this out, man. You've got great data. I don't know why I don't think I fundamentally did anything different than you,
I just have
but
bad luck with computers.
what do you think of this? No, you just don't worry about it. This happens. You just be persistent, keep trying. You would have got the same thing.
It took me like 40 times to film this because I could not find a place to film this, so I had to go to my neighbor's house. So this is really exciting that I actually got a video that worked.
No, it came out insane. It came out beautiful. We'll be able to conduct the analysis, and it's going to come out great.
Because like everywhere I went, like there was like a little bit of a bump somewhere, and it just,
Look at how you really have three motions here. You have speeding up in the negative direction.
yeah, because it's like sped up and it slowed down, and then as soon as I got to the middle and pulled shut, it sped up again and then slowed down again. So
I would say that you've got this middle period where you're going constant velocity, and then in the end you're slowing down, as shown here with the slope getting less steep. Oh, did it speed up again in the negative direction over here? What's going on here?
it's probably just my dad choked the camera or something.
Okay, all right. So we probably won't use that data. We could go up to like 18 seconds or
I'm
whatever.
so excited because like that video actually worked.
Okay, you know, paused.
Yeah,
Oh, it didn't just work. It came out amazing. I mean, okay, so this computer seems like it's running a little slow because I hit close and it's not doing anything. So I'm gonna hit save right away and save your stuff.
That would be a good idea.
And then we'll just keep going. It's doing okay though. It's doing the screencast. Can I call this this one? Can I replace this one since it came out really good?
Yes. I have
Okay.
it on my USB too. So.
All right, good. And I'll hit save. Now let's do the rest of this analysis real quick. I'll hit table. I'm gonna get rid of Y. I actually don't want it. I just want X. And then Apple A, Apple C, and then Open Logger Pro. You didn't do this part yet, right?
No, because it didn't really.
Okay, so this will probably be pretty helpful then for a lot of people, just to see how to do it. And then Apple V copied your data over, and then I'm naming stuff. This is time, T, seconds, right?
Wow.
Oh, I
It's
spelled it
second
wrong.
minutes.
Whoops. I'll have to fix that.
We're now counting in seconds.
That was funny.
Ashley's
Let me pause this for a sec. So then I put position here. X meters. Okay. All right. So now okay. All right, so check it out. Control C, Control V. Now I did that while I was clicking on the graph, so now I have two graphs, Apple R. Okay, so now my two graphs are arranged. It's going slow only because the memory's low. Now I'm going to create a column and make velocities out of the data I have. You guys don't have calculus, but you do know that the slope of a position time graph is what? Okay, in physics, what does it mean when you take the slope of a position time graph? You do know this.
That's the velocity.
Beautiful, Kai. Good. You've just proven yourself to me very well.
Thanks.
So, no, I'm serious. It means something. So, now I'm going to create a new column. Go Data, create new column, new calculated column, and I'm going to have Logger Pro calculate from those positions and times. It'll calculate velocities. And it does a nice job of this. So I'm going to call this velocity, and the velocity is changing every second, right? So I'll call this V, meters per second, and then I'll go here and I'll choose a derivative. It's a calculus thing we use called the derivative. And again, it simply means find the slope of the curve, okay? So it's gonna, this red curve we have is position. The derivative of position is what? It's velocity. So derivative, again, is a fancy way of saying find the slope of a curve. So I'm gonna hit done. Watch what happens. See this new column? Now you have all those velocities at those different moments in time. I find this is a little better than doing it with Tracker, because Tracker's velocities have come out weird in a few cases. And then I just change this lower graph to velocity. So now I have a beautiful stack of graphs. I'm probably going to want to like auto scale this from 0 maybe. Oh, it's a little funk, so I'm going to make it look nicer. I'm just going to play a little bit. Let's say 0.5. And this is what I think Logger Pro is really good at, is just helping you play around with the graphs and figure out what stuff means. I'm going to change this to -6, and you'll be able to make these look pretty on your own. I'm just doing what I can now. I probably went a little too far there.
Yeah.
But
Like that one.
okay.
0.5.
Okay, how about 0.5 is nice. That's a good idea. So in this section here, we have, so what you need to do here is, it requires some imagination. Because it's real data, it's messy. But I see a section here right now where we have a negative slope. That's probably when we were speeding up. I'd say we can approximate that with a line. So this is your first acceleration. And if you're not happy with where these brackets lie, you can move them around directly. You just click on the bracket and you can move them around, and you'll see the slope will change a little bit. So wherever you think you can move this bracket so that you have the best estimate of your acceleration during the period when your car is accelerating is fine by me. And then over here, I'm thinking this is when the car was going constant velocity. So I wouldn't do a best fit line there. I would just find the average of those points and call that my average velocity. Make sense? So analyze statistics. I highlighted that section.
Running out of time.
Okay. And then I think this period here, it gets pretty messy. But this period here looks like that's when the car slowed down. So A lot of people have a speeding up and a slowing down. You really have a speeding up, a constant velocity, and then a slowing down.